Well, good evening. The topic that we'll be discussing today is a popular CNN architecture, that is AlexNet. Now, first of all, why we say the name to be AlexNet? Because it was developed by Alex and his colleagues. So because of that, the name was given to be AlexNet, Alex Neural Network. Then is who is Alex? Alex is a computer scientist who worked in a Canadian university and has worked in the field of ANN and deep learning. Then is what they have done in this AlexNet. They basically won a challenge in year 2012, and the name of this challenge was ImageNet Large Scale Visual Recognition Challenge. Just like we have hackathons nowadays, similarly at that time, this was a challenge that was there. Now, what was this challenge? In this challenge was about image classification. So what the target was that these people need to develop an algorithm and model for classification of images, and the dataset that was taken was an ImageNet dataset in which there were million of images, labeled images were there. That means a supervised form of learning was there, and thousands of categories were there of the images, and the target evaluation parameter was the accuracy. So they developed this model, they developed an algorithm, and they won this challenge. Now, what impact did this model had on the other models? Now, this model acted as the basis uh, on which advanced models and more accurate models came, like VGG, that is Visual Geometry Group, GoogleNet, ResNet. So these are more accurate models that are available as of now, as of today. And now in this model there are 8 layers. Out of these 8 layers, 5 are convolution layers, 2 are fully connected layer, and 1 is a linear layer. So 5 convolution, 2 fully connected, and 1 linear layer. The same is represented in this form of representation, where we have CNN, where CNN stands for a convolution layer, followed by that is RN. RN is response normalization. MP is maximum pooling. Then again CNN cube, that is again a convolution layer, followed by max pooling, followed by FC, that is fully connected layer, followed by that is DO, that is a dropout, then a linear layer, and softmax. So if you could see the first part, then it is square. So that means there are 2 convolution layers. Next is CNN cube. So 3 convolution layers. 2 and 3 is 5 convolution layer. Similarly FC, it is a square. So it is a square. So 2 fully connected layers, and then is a linear layer. Now let us identify what is the purpose of each part. The first one, we have convolution layer, so it performs convolution operations. What happens in convolution operations? We are able to determine the features that are present in the image. What features? Features like we have the texture, we have the color, then we have edges, we have boundaries. So such kind of features are identified. Then is response normalization. In response normalization, we have different kind of normalization: z-score normalization, min max, feature scaling, probability distribution normalization. So we are trying to scale it in a particular range, and what we are trying to scale is we are trying to scale the features that are obtained from previous convolution layer. Followed by this is MP, that is maximum pooling. The purpose of maximum pooling is to reduce spatial dimensions. What will happen by after when we reduce the spatial dimensions? We will get less computational complexity as the data is reduced, the image dimensions are reduced. Then is the next part, similar to the first one in convolution layer, where we were extracting general features. Here we will be extracting more complex features. Then is the third part. Here FC is there, that is a fully connected layer, that is just like an ANN. where we have input, we have hidden layer, and we have output layer. But here we have DO also. DO means dropout. We'll be able to drop out certain neurons. Which neurons will be able to drop out? Neurons that are underperforming, neurons that are not further required. So that will be removed in this part. Then the next part is the linear layer. In linear layer, we have a two-dimensional feature map that was generated from the previous steps. So it will be converted into 1D. 2D to 1D conversion happens at this layer. Finally, we have softmax. This is an activation function. Just like we have step functions, sigmoid, ReLU, 10H activation functions. Similarly, we have a softmax activation function. What it generates is, it generates probabilities. And on the basis of probabilities, we'll be able to classify the things. So this was all about AlexNet. And if you got some knowledge from this video, then do like, comment, share and subscribe. And thanks for watching.